Welcome to part 4 of the Modular Knock series. In this video, you're going to learn about the validate knock command. At this stage, we know how to connect all AXI buses by utilizing XPMs and how to define multiple constraints like connectivity, addressing, QoS, and bandwidth by using constraint files, or XDCs. The final step in this three-step process is to run the validate knock command. This video focuses on this command. The validate knock command validates the knock topology for the entire system. The validate knock command does the following. Looks for various knock instances present in the BD, DCP, EDIF, and RTL files. Looks for XDC constraints comprising of apertures and QoS. Passes this information to the knock compiler to create a system-level knock solution. Additionally, this command also runs DRCs at a system level. The result provides a complete knock solution that can be observed in the knock viewer, showcasing the route results. Users can run this command manually, but the command is also run by the flow automatically at 3 different stages: synth design, link design, and place design. Before we jump into demonstrating running the validate knock command manually, let's look at the difference between the knock view when opened from the block design versus after using validate knock. Let's open the block design and look at the knock view. The knock view can be seen on the right side by clicking the knock tab. Once we click the window option from the menu bar and select knock, we can look at the knock objects on the left and the knock QoS in the lower half. The knock objects in this view are limited to the number of knock instances present in the block design. We can observe that there are 6 master objects, 2 slaves, and 1 DDR. Let's look at the aggregated solution by using the validate knock command. In the knock objects pane on the left, we can observe that there are now new knock objects present in addition to the objects present in the block design. We have 3 additional masters and 2 additional slaves. Let's compare this again with the block design view. We can observe that there are fewer knock objects in this view, and these objects are limited to the block design knock instances. Let's now move on to the validate knock command demonstration. We'll run the validate knock command manually through the Tcl console. The command initiates RTL elaboration and kicks off the knock compiler. The successful result for the knock compiler can be seen in the Tcl console. The knock view is shown on the right-hand side, consisting of all the knock instances. The knock objects pane on the left-hand side displays all masters, slaves, and any DDR instances present in the overall design. By clicking each instance, we can observe each instance in the knock view. Under the master section, we can see 1 memory-mapped NMU and 2 AXI streaming NMUs that were stitched in the RTL. There are 6 NMUs that are part of the block design. Under the slave section, we have 2 NSUs that were stitched in the RTL through XPMs and 2 NSUs that are part of the BD. Lastly, we see 1 DDR instance that was configured through the knock IP in the BD. The knock QoS tab in the lower half displays the QoS parameters for each path. In our XDC file, we defined the QoS parameters for the memory-mapped path from the PL to the DDR with the read and write bandwidth set to 400. The same values can be observed in the knock QoS tab. In our XDC, we did not specify the QoS parameters for the 2x2 streaming interfaces. Therefore, default parameters are used for the 4 streaming paths. We can also see the QoS parameters for the 6 paths that were defined in the BD. We can see the overall system-level NOC view, and everything works as expected. To recap this video, we discussed the validate NOC command, focusing on its use and highlighting the different stages in which it gets executed. We showed the differences in the NOC view when we open it from a block design perspective versus after using the modular NOC solution. We ran the validate NOC command manually to show the system-level solution and QoS properties. That will wrap it up for this video. The next video in the series will discuss the DFX flow and a virtual NOC interface.